Hello students, welcome back. Now we will start a new chapter which is an acids, bases and salts. In this video, we will learn about the acids and bases. Now, what is an acid and a base? What do you mean by an acid? An acid is a compound when you dissolve it in a water or when you dissociate it in a molten state, it will liberate H plus ions or H3O plus ions. When you dissolve it in a water or when you dissociate it in a molten state, it will give us H plus ions or H3O plus ion, that is hydronium ions. This is, if it gives H plus ions or hydronium ion, then it is known as an acids. Now what do you mean by base? When you dissolve it in a water or in a molten state, and if it gives you OH minus ions, then it is a base. So what is an acid and a base? Ionizable and non-ionizable compound. There is an ionizable compound, that means which gives us ions when it is dissolved in a water, and if it gives in ions, then it is called ionizable compound. And what is non-ionizable compound? Which does not dissociate into ions when dissolved in water or in a molten state. Molten state, that means when it is in a melting state, right? Now, what was the Arrhenius theory of acids and base? The one which I told you just now. What was Arrhenius theory? Arrhenius acid is the means that when any compound, if it dissolves in a water and it dissociates to give H plus ions or H3O plus ions. What is Arrhenius base? When dissolved in water and it dissociates to give hydroxyl ions, then it is known as a base. Like I am giving you an example. Let's say HCl. HCl, when you dissociate in ions, when you dissociate in a molten state, it will give us H plus plus Cl minus. Or if you dissociate into HCl plus H2O, it will give us H3O plus plus Cl minus. Similarly, when you are dissociating sulfuric acid, so here it will give us 2H plus plus SO4 2 minus, and HNO3, it will also gives us H plus plus NO3 minus. So as we can see that it is releasing only one H plus ion in case of HCl, then it is known as a monobasic acid. Why monobasic acid? Because it is giving us only one H plus ions. It is giving us only one H plus ions. But when it is in case of sulfuric acid, H2SO4, it is giving us 2H plus ions plus SO4 2 minus ions. Then it is known as a dibasic acid. Okay. Let us take one more example. H3PO4, phosphoric acid. In case of phosphoric acid also, it gives us 3H plus ions plus PO4 3 minus. That means it has given us 3 hydronium ions or 3 H plus ions. Then it is a tribasic acid. Nitric acid is also a monobasic acid. Why? Because it gives us 1 H plus ion. Okay. Now, base. As I told you that when it dissolves in a water and if it gives us OH minus ion, then it is known as base. Let's say NaOH. NaOH, if it dissociates, it gives us Na plus plus OH minus, right? In this case also it is known as this is a base. KOH, it will also dissociate into K plus plus OH minus. CaOH2, it will break into 2 Ca plus plus 2 OH minus. Ca plus plus 2 OH minus. Now, how will you identify that whether it is an acid or whether it is a base? How will you identify a compound? So for that we need to do a physical test, and this physical test is possible only in two ways. Either by their taste or by the effect of an indicators. So an acid tastes sour. Acid tastes sour, whereas a base tastes bitter. It tastes bitter in nature. A base is a bitter in nature, whereas acids are sour in nature. Okay. Now, but the method of testing an acid is not a good idea. Why? Because we know that it is highly corrosive in nature. It is highly corrosive in nature. It can contaminate. Okay. Now, and the other method is indicator. What is an indicator? Indicator is a substance. It is a chemical substance which shows a change in its physical properties. Which shows a change in its physical properties, mainly color or odor, when bring in contact with an acid or a base. Like when we in the junior classes we have done few experiments with the help of the pH or with the help of the litmus paper. We have examined that whether the compound is an acid or basic. So it is a chemical substance which help us to identify that whether it is an acid or base by changing its color or odor when it is brought in contact with an acid or a base. Okay. Next, so what are the indicators which we know? Litmus paper, methyl orange, phenolphthalein. So in litmus paper, in a neutral solution, it will gives us purple color, and if it is an acidic solution, it will gives us red color. Litmus paper, if it is acid, it will convert blue to red, but if it is basic solution, it will convert red to blue. Basic blue, basic blue. Okay. So there are two variants of paper, red litmus paper and blue litmus paper. If it is an acidic solution, it will convert blue to red. It will convert blue litmus paper to red. But if it is in a basic solution, it will convert a red to blue. Clear? Now methyl orange. If you add methyl orange solution, you will see in a neutral solution it gives orange color only. It gives orange color. But if it is an acidic solution, it will gives red color. If it is an acidic solution, the methyl orange, if we pour an methyl orange, few drops of methyl orange in an acidic solution, it will give red color. In basic solution, it will give yellow color. Phenolphthalein, in a neutral solution, it gives colorless. It remains colorless. In the acidic solution also it remains colorless. But in basic solution, it gives us pink color. Clear? Now, what are the acid-base reactions? We need to know what are the acid-bases reaction. So, reaction of acid and bases we will study. When acid, any acid, if it reacts with an active metal, if any acid reacts with an active metal, it gives us salt, hydrogen plus heat. What does it give? It is it is a mathematical formula. It is like a mathematical formula that when any acid, if it reacts with an active metal, it will gives us salt, hydrogen and heat. Right? If any base reacts with a metal, it will also gives us salt, hydrogen and heat. So these are the examples. When you react hydrochloric acid with Mg, magnesium, it will gives us magnesium chloride and hydrogen and heat. When you react sodium hydroxide, which is a base, with metal, then it forms a sodium zincate. This is known as Na2ZNO2 is known as a sodium zincate and hydrogen. So as we know that more reactive metal displaces the less reactive metal from its base. So when you react more reactive metal, that means Na plus MgOH2, it will replace Mg and it will give us 2NaOH plus Mg. Clear? Now, reaction of an acid with metal carbonates and bicarbonate. When there is a reaction with any carbonate, so what is carbonate? CO3 2 minus, right? CO3. So definitely it will give us carbon dioxide, right? It will definitely give us carbon dioxide. So when any acid reacts with a metal carbonate or bicarbonate, it will definitely give us salt, water and carbon dioxide. Now see, HCl plus CaCO3. So it has given us salt, calcium chloride, water, H2O and CO2. Similarly, when it has reacted with magnesium bicarbonate, sulfuric acid, it has given us magnesium sulfate, water and carbon dioxide. So there is a effervescence indicates the liberation of CO2 gas. Now let me tell you, see CaCO2, Ca when reacts with chlorine, it will form CaCl2, right? Now there what is left? 2H and CO3. Now 2H. So out of 2H, there is H2O. CO3 can be broken down into CO2 plus O. Right? Now 2H plus O makes H2O and CO2. Clear? And now neutralization reaction. By the word only you can understand it is neutralizing the reaction. It is the acid and base is neutralizing their effects. It is neutralizing their effects. So what is the reaction? When any acid plus when reacts with a base, it gives us salt plus water and heat. Let us take an example. H2SO4 sulfuric acid when reacts with a magnesium oxide, it gives us magnesium sulfate, water and heat. Clear? Now when any reaction of non-metal oxide with bases, it are acidic in nature. When non-metal oxides are with bases and non-metal oxides are acidic in nature. Clear? It is very acidic in nature. Now base plus non-metal oxide. So let us take an example, base NaOH. When it reacts with a non-metal oxide, carbon is a non-metal, carbon dioxide, it forms a sodium carbonate and water, okay, which is acidic. Now manufacture of acids and base. Now let me tell you, when any non-metal oxide reacts with water, it forms an acid. I am repeating myself. When any non-metal oxide reacts with water, it forms an acid. It forms an acid. For example, sulfur dioxide is reacts with H2O, it forms sulfurous acid. When sulfur trioxide reacts with water, it forms a sulfuric acid. Nitrogen dioxide reacts with the water, it forms a nitric acid plus oxygen. So non-metal oxides are thus referred to as acid anhydrides, as I told you in the last slide, previous slide. Okay, that non-metal oxides are thus referred to as acid anhydrides. Now when you react hydrogen plus halogen, the 17th group, then also it forms an acid. If it reacts with chlorine, it forms hydrochloric acid. If it reacts with fluorine, it will form hydrofluoric acid. Okay, so HCl now when reacts with water, it forms HCl aqueous. It forms an aqueous HCl, right? And when you react hydrogen with chlorine gas, it will form dry HCl gas. And then when you react dry hydrogen chloride gas with water, it will form an aqueous hydrochloric acid. Clear? Now, when metallic salt reacts with concentric sulfuric salt, it gives us salt plus more volatile acid. Now, what do you mean by volatile acid? Volatile acid are the acid which can vaporize easily. Volatile acids are the acid which can vaporize easily. So, NaCl when reacts with H2SO4, it gives sodium sulfate and HCl. Clear? Now, when potassium nitrate reacts with sulfuric acid, it gives potassium sulfate plus nitric acid. So basically you all have to remember the formulas, the basic formulas, then easily you can solve any equation, any chemical equation. Now let me tell you very clearly and listen to me very carefully that when any metal reacts with oxygen, it forms metallic oxides, and this metallic oxide is known as base. When any metal reacts with an oxygen, it forms a metallic oxide, and this metallic oxides are known as base. Now when you react this metallic oxide with water, then it will form metallic hydroxide, which is an alkali. Clear? I am repeating myself. When any metal reacts with oxygen, it forms a metallic oxide, which is a base in nature. Clear? Metallic oxide only we call it base or basic. But when this metallic oxide reacts with the water, it forms an alkali. It forms an alkali. This is why it is known as all bases are alkali, but all alkalis are not bases, because it is all maybe all bases cannot dissolve in water, right? So this is why it is known as all bases are alkali, but all alkalis are not bases. Okay, so any metal reacts with oxygen, it forms a base, metallic oxide. Okay, so let's say Na plus O2, it gives Na2, Mg plus O2, it gives MgO. Now this Na2O, sodium oxide or magnesium oxide, if you react with water, it will give us NaOH or MgOH respectively. This MgOH or sodium hydroxide or magnesium hydroxide is an alkali. Is an alkali. There is another example also that see, this example is given Na2O plus water, it gives NaOH. Now this is an alkali. The aqueous is known as alkali. Metallic hydroxide is known as alkali. When any water zinc metal reacts with water, it forms zinc oxide and water, hydrogen and hydrogen. Okay, when any metal reacts. Now ammonia plus water, when it reacts, NH3 plus H2O, it will give us ammonium hydroxide. It will give us ammonium hydroxide. See, there is one N and H3 H2O. So NH4 ammonium, NH4 OH, ammonium hydroxide. Now water. Acids and bases in water. We know that when when added to water, acid and bases dissociate into H plus ions and OH minus ion, right? When we dissociate water, it gives us H plus ion and OH minus ions, hydronium ions as well as hydroxyl ions, right? Now what are the differences between base and alkali? Bases undergo neutralization reaction with acids. They are comprised of metal oxide, metal hydroxide, metal carbonate, metal bicarbonate, and most of them are insoluble in water, right? Most of them are insoluble in water. They are metallic oxide. But an alkali is an aqueous solution of a base. As I told you, when metallic oxide dissolves in a water, it forms an alkali. So it is an aqueous solution of a base, mainly metallic hydroxide. It dissolves in water and it dissociates to give us OH minus ion. This only dissociates to give us hydroxyl ions. So all alkalis are bases, but all bases are not alkalis. Clear? Now dilution. How will you dilute? Dilution is a process of reducing the concentration. Concentration, that means the solute concentration is more and the solvent concentration is less. But when we are saying diluting, that means in that case the water concentration is more and the solute concentration is less. I am repeating myself. When we are saying that this solution is diluted, that means in that case the water concentration is more. But when we are saying it is concentrated, that means the solute concentration is more. Clear? So dilution is the process reducing the concentration of a solution by adding more solvent. There is more water in it. So it is a highly exothermic process. Definitely when you are adding water, it is liberating heat. So it is a highly exothermic process. To dilute acid, keep it in mind, this is very important. To dilute acid, the acid must be added to water. We can, means water is there, then we are adding acid. We cannot do like this, that acid is there in the container and we are adding water. No, it will spurt. And it can cause you severe injury. Clear? This is why the acid must be added to water, and that too, when you are adding the acid in the water, it should be continuously stirred. Okay. So acid is added to the water, not water is not added to the acid. Now strength of an acid. How will you determine whether it is a strong acid or strong base, or it is a weak acid or a weak base? When you dissociate it, and if it dissociates completely, if all the molecules, if it completely dissociates all its ions into respectively H plus ions, then it is a strong acid. If it partially dissociate, or if there are very few molecules which have dissociated into H plus ions or OH minus ions, then it is known as weak acid or base. I am repeating myself. When all molecules of a given amount of an acid or a base dissociate completely in water to their respective ions, H plus ions or OH minus ion. Suppose you have taken 10 molecules of HCl. Okay, in that case all the 10 H plus ions you have liberated, then it is a very strong acid. Okay. Now suppose you have taken CH3COOH, acetic acid. In that case 10 molecules you have taken, out of that 10 molecules only 2 molecules have dissociated into H plus ions, then it is a weak acid. Clear? Say similarly in case of base. So what is weak acid or a base? When only few molecules of a given amount of an acid or base dissociate in water to furnish the respective ion, then it is known as weak acid or base. See, with the help of a diagram I am trying to explain you. See, uh, weak acid and strong acid. Ha, it is there. Okay. There in this case you see Ha. How many molecules we can see? 1, 2, 3, 4, 5. Out of the 5 molecules, 2 molecules were unable to dissociate into H plus ions, but 3 molecules were able to dissociate. So this is why all the molecules could not dissociate into H plus ions. So this is why it is a weak acid. But in this case, you see, all the 5 molecules has dissociated into H plus ions. So in this case, it is a strong acid. So when it has a higher pH than strong acid. Why? Because it is alkaline in nature. It has a not alkaline in nature, it is an acid in nature, but the pH is higher. The less the pH value, more the acidic. Less the pH value, more the acid. As it has dissociated all the H plus ions, so it has very low pH, so it is more acidic. Clear? Now similarly in case of a hydroxyl base, see, there are also 5 molecules of 1, 2, 1, 2, 3, 4. 4 is there. 1, 2, 3, 4. Yes. 4 are there or 5 are there. Yes, 5 are there. So in this case also see 2 molecules BOH and BOH. They were unable to dissociate OH minus ion. As a result, it is a weak base. So when it is a weak base, in this case, the lower the pH, stronger the base. Higher the pH, lower the base. High the pH, stronger the base. Lower the pH, weak the base. Clear? So in this case, you see, in strong base, all the molecules have been dissociated into OH minus here. So it has high pH. I am repeating myself. When the pH is very low, it is very highly acidic. When the pH value is a little bit high, it is a weak acid. When the pH value is very high, in case of base, it is a strong base. When the pH value is comparatively lower, then it is a weak base. Clear? Next, so dilute acid contains less number of H plus ions unit per aqueous volume. Dilute acid contains less number of H plus ions per unit volume. Okay, and concentrated acid contains more number of H plus ions per unit volume. Clear? So it has as I told you, because dilute acid contains less H plus ion, because it is not dissociated, and concentrated it is more number of H plus ions are there. You can see in this 1, 2, 3, 4 all are dissociated, right? See, so it contains less number of acid per unit volume, and it contains more number of acid. It has very low pH, that is why it is concentrated acid, and it has a higher pH. In case of base, it contains less number of base molecules per unit volume, but it contains more number of molecules per unit. It has high pH, so it is a concentrated base. If it has a lower pH, then it is a dilute base. Okay, so I hope this is clear to you all. And if you have any problem, so please kindly let me know. Please watch the video and do give me the feedback. Take care. Thank you.